But before we do that, let's take some questions from homework if anybody's got any. Okay, if there's nobody has any questions, then let's just kind of move on forward. If you change your mind, we can always come back and hit those a little bit later, but all right. Today we're going to do section 15.5. Where we're going to be talking about mathematics and finance. So, when we talk about financial stuff in mathematics, primarily we're going to be interested in interest. When I say interest, does that mean stuff that fascinates you? No, Mr. Kulik. We're talking about interest in regard to like banking stuff, right? Money, yeah. So there's really, two types of interest. So the first type is simple interest. In simple interest, the interest is only paid according to the principal, the initial investment. And let's define what some of these letters are. So FV is the future value, PV is the present value, R is the interest rate as a percentage, and N is the number of years. So let's take a peep at a quick example. So if you invest $200 or $2,000 at 6% interest rate, how much money do you have in the account after 3 years? So there's my simple interest formula. What part of the simple interest formula are we solving for in this question? FV, right? Because you're looking for the account after 3 years. That's a future value, okay? So where does the 2,000 go? That's the PV. Where does the 6 go? That's R. And then what's the value for N? Gotta be 3. So we can fire up the calculator. So I get 2,360 bones. So how much interest did I earn? Just as a secondary question. Yeah, and you could just do that by doing future value minus present value, right? Everybody cool with that? Now, in general, do financial institutions use simple interest? Nah, man. Why? Because it's kind of a bad deal for all parties involved, right? Why? Because after the first year, you have more than $2,000 in your account, right? You've earned $120 in interest, you have $2,120. So the interest you earn from year 2 to 3 should be representative of that new account balance rather than the old one. So when we calculate interest that way, that is called compound interest. Where the interest is always calculated using the current account value. So this is our new compound interest formula. FV, PV, and R and N are all still the same thing. This is a simple interest formula, so I'm not going to write them again. The K is new, as a new parameter for this equation, so let's say what that is. The K is just the number of compounds per year. So I'm guessing that probably a lot of us have a bank account. If you have a savings account and you've ever looked at the bank statements, you'll notice that you don't get interest at every single statement. Typically, banks pay out the interest like 4 times per year, kind of quarterly. So this value for K is always going to be kind of a verbal indicator in the problem. So you're going to have to make sure that you're reading carefully. Let's do an example of that. And then we'll, oops, too far, Mr. Kulik. Where did I go? I lost my spot. There I am. Okay. Hi. So if we invest $2,000 at a 6% interest rate compounded annually, how much total money do you have in the account after 3 years? And how much interest did you earn? What words in this problem are going to tell me which one of the two interest formula, or which of the two interest formulas should I be using? Yeah, compounded is the key word there that I need to see to tell the difference between simple and compound. Evan, this is for you.
Thank you.
You're welcome. Okay, and then what part of this formula am I solving for? Yep, still FV. And everything else, or what's PV then? 2,000. Yep. R is 6. What's K? 1. Hopefully you realize that annually means 1 time per year. And then what's my value for N? 3. So this is almost the same situation as the previous one, but instead of compounding with simple interest, we're using instead of using simple interest, we're using compound interest, right? But all the rest of the parameters are the same. Let's see how much of a difference this makes. So $2,382.03. So how much interest did I end up earning? $382.03. How much better was this than the simple interest? $22 maybe? Over 3 years? Not so impressive, right? What if we bump that out to, say, 30 years, though? And let's see what kind of a difference that makes. So if I simple interest for 30 years, $5,600. Compound interest for 30 years, $11,486.98. Much bigger difference there, right? $6,000 or so. Be pretty miffed if I missed out on that. Tommy.
Kind of off topic, but how do banks benefit from giving people compound interest?
Well, in general, the way banks are going to make money, so they pay you interest to hold on to your money, right? They use your money to give loans to people, and they charge them a higher interest rate than they're giving you, so they're making a profit on this for basically just acting as a middleman. Well, they assume some risk in the operation as well. Like if the person defaults on their loan, they may not be able to recoup the full value, but that's ostensibly how the bank is making money. They do a variety of other things, but like at the most basic of levels, that's what a bank is designed to do, or how it's making money. Is that cool? Okay. All right. So let's look at the effective K then. Right, that seems to be the thing that's maybe not so easy to understand. So some common values of K. Annually means K is 1. If I say semi-annually, what would K be? It would be 2. Semi is half, right? Like a semicircle is half a circle. Another common one maybe is quarterly. So there K is 4. Monthly, what would K be there? 12. What if it was weekly? 52. And what if it was daily? 365. Let's look at the effective K. So I'm just going to go ahead and grab that situation that we were working with earlier. So this is when K is 1. We got this 2382. And we're just going to go and look at the effective K. So I'm going to change K from 1 to 2. What do you think? Little deal, medium deal, big deal? $6. Not much of a deal. So let's see, let's change 2 to 4. You think this is going to have more effect or less effect? Let's see. So we improve $6 to going from 1 to 2. We improve $3 going from 2 to 4. Let's go to 12. So that's 3 times more now. What do you think? What do we got? We picked up about $2. Let's go to weekly. That's 52. Yeah, about 80 cents there. Let's go to 365. Notice every time we do get an improvement, right? Like more compounds is better, but like the amount of improvement you're getting is, well, we got 20 cents better that time. It becomes diminishing, right? As K gets bigger, it has less and less of an impact. Still better, right? But less and less of an impact. What if we instead wanted continuously compounding? What would the K be for continuously? The K. How many compounds per year are occurring if it's compounding continuously? Infinite, right? Continuously means like at every instant. So there would be infinitely many. Now we can't exactly go and plug in infinity into our formula and evaluate that. So we're going to have to do something different here. So let's take our compound interest formula and, and I'm going to go ahead and rearrange things a little bit. So I'm going to start just by rewriting NK as 100 over 100K over R times NR over 100. And you might say to me, Mr. Kulik, why the heck can you do that? Well, yeah, if I multiply those two things together, I just get NK. So I haven't really done anything different. And why would I want to? So I certainly can do this, right? We've established that because it's still the same thing. Why would I want to do this? You're going to see in a moment. Okay, so we'll table that one. I'm going to make a substitution. Now, I'm going to say that I'm going to replace 100K over R with X's. So if 100K over R is equal to X, what's R over 100K equal to? What was that? 1 over X. Yeah, that's right. If you know the answer, just holler it out. Or even if you not sure that it's the answer, you can holler them out. There's no penalty for being wrong, right? That's how we learn. So that piece becomes X. And I'm going to just rewrite this as like an exponent of an exponent, which I can do since the exponents are being multiplied. Everybody's cool with this? Anybody recognize that? We've seen it this chapter. Let's go back to before spring break. I know, that's asking a lot. And we'll go back through here. Take a look at this right here. That look like what we have that I highlighted? 1 plus 1 over X to the X. We know the limit as X goes to infinity for that is equal to E. So we know we have K going to infinity, right? Well, that certainly means that 100 over, or 100K over R would also have to be going to infinity, right? And since that's just X, X is going to infinity, right? So that would give us this then. I can replace that piece that I've highlighted in yellow with E, and this becomes our formula for continuously compounding interest. So now we have a third interest-related formula. Let's see how much of improvement continuous compounding was over 365. What do you guys think? I don't think we're going to be real impressed. 4 cents. Now, I want to point out that all of these were an improvement over annually compounding, right? Each time that K got bigger, we did get an improvement, but it's just not, a really impressive improvement. Okay. Next up, let's do an unrelated example. So we have an account that earns 6.5% annual interest compounded monthly. And we want to find what would the equivalent interest rate be if it was instead just compounded annually, right? So I'm going to kind of set up two different pieces. We'll do this we'll have a monthly part or piece and an annually piece. Now, if I look at these, one's compounded monthly and the other's compounded annually, so I know I just need my standard compound interest formula. So far, so good. Okay, well, let's start filling in. Obviously, I don't have all the information I need for this, so we're going to have to be a little bit clever about how we do this. But let's start filling in what we can. So let's look at the monthly equation. What can I fill into the monthly equation? I can fill in R, which is 6.5, and what else can I fill in? K, which is 12. And I'm going to then just rewrite this as 1 plus 6.5 over 1,200 to the 12th, and then all of that to the nth. Okay. That's all we can fill in for the monthly one, right? Let's go to the annually one. What can we fill into for the annual equation? That's what we're asking for, is the R, right?
Okay.
The K. What is the K for the annual? Just 1. So I'm just going to write it like that. Not even going to show the ones plugged in. We're cool with that? Now let's compare. Same, right? And if these two equations need to do the same thing, which was it asking for, I can take this stuff and set it equal to that stuff, right? If these two equations have to have the same result, everybody buy that? So to solve this for R, what do I need to do? Subtract 1 and multiply by 100, right? Come here. So I got that's about the same as a 6.7% interest. We cool with that? Okay. This process actually turns out to be quite a useful one. Why would this process be useful? Yeah, go ahead, Lexi.
You can decide which one's going to be.
Right. So if you have two different accounts that compound at different interest rates with different compounding periods, you can figure out which one of these is going to be the the better investment, right? So this actually gets its own special name in financial mathematics. This is called the annual percentage yield, also abbreviated as APY. And we're going to just formularize that process that we did up above. So if I look at what I did to solve for R, I did 100 times the quantity 1 plus R over 100K to the K minus 1. And again, all these things we've defined here, so we don't really need to do this again. This APY, just again to reiterate, is like the equivalent interest rate on an annual compound, right? So just taking whatever it is and converting it to an annual compound. All right, so that allows us to answer a question like this. So we have, which savings account is the better investment? One that pays 7.8% interest compounded quarterly, or one that pays 7.65% interest compounded quarterly? And I think I said quarterly both times, and it definitely says weekly on the problem. My apologies. So I have two options, right? So to figure out which one is better, I'm just going to calculate the APY for each of them. And which one, how would I know from the APY which one would be better? Yeah, you just want the bigger one, right? That's exactly right. So I'll just write both of those down. Again, all I'm doing is just some plugging and chugging here, right, guys? Nothing too tricky. And I'm going to use the fraction command while I do this, just so it makes it a little bit easier to go back and edit what I just typed in, so I can get away with like not having to type everything in all over again. So the first account's about an 8.03. And the second account, I need to change the 4 to 52 in two places. And the 7.8 to a 765. And I get 794 APY. So which one of those is the better investment? The first one, because it's a bigger percent. You guys feel pretty good about that? Yeah. Okay. One more concept to talk about here. So what we're going to be talking about next is something called an annuity. So an annuity is just some account into which a sequence of regular payments is made. I'm sorry, just a sequence of payments is made. And what we're going to be interested in this course is something called the ordinary annuity. So this is an account, or let's just say it's an annuity, where the payments occur at the same time and for the same amount. So, think about life. What's an ordinary annuity sound like? Are we making payments that are always the same size at kind of always the same time? Yeah, like a rent or a mortgage or a loan. Yep. Bills, yeah, primarily. What else? This one's a little harder for typically high school students to catch. How about retirement savings? Right? Like every paycheck, usually you contribute some part of your paycheck, every paycheck, towards your retirement savings, happening at the same time every month for the same amount. Typically, it's a percentage. So we have kind of two different types of annuities. You have like the investment annuity. So our equation for that is going to be this. FV equals R times the quantity 1 plus I to the n minus 1 all over I. So here we have three new parameters. Here we have this R, cap N, and I that are new. So let's define those. R is that regular payment amount. So that's whatever your monthly payment is or whatever. I is just going to be R over 100K. And cap N is just N times K. Where that R, K, and lowercase n are still the same as what we've been using in the previous equation, so I'm not going to redefine those there. Feel okay with everybody on what everything means? So let's look at an example here. At the end of each quarter, Sarah makes a $500 payment into an annuity account. If her investment earns 7.88% annual interest, compounded quarterly, what will the value of Sarah's annuity be in 20 years? So this sounds like the investment annuity situation that we just described. And what parameter are we looking for? That's a future value, right? Okay, so let's start filling in the rest of this. What is R? 500. And now I'm just going to write this formula with the I and N in it. And I'm just going to write off to the side what I is. So remember, I was R over 100K. What is R in this case? Little r. That's the 7.88. And what is the K in this case? 4. And then cap N is little n, which is how much? 20, that's the length, and then times K again. So that's everything I need. We'll go back to the calculator. And here I'm going to abuse the heck out of that fraction command. If you haven't been using this regularly, boy, it makes life a whole lot easier on these ones, because if you try to do this without using that fraction command, boy howdy, the parentheses get to be pretty overwhelming. But by using the fraction command, I can ostensibly just do exactly what it looks like on my sheet of paper. So I get $95,483.39. Everybody cool still? No big deal, right? Just plugging and chugging here, not a whole lot of difficulty. The hardest piece is just like being familiar enough with the vocabulary to know like where the numbers need to go. But like, come on, man, this is some of the stuff we've done before. This is a cakewalk compared to like, oh, here's a couple of equations for three-dimensional vectors, line equations, and figure out like what's going on here. Like, that was much more confusing than this was. Now, if we have an annuity that's like a loan, that's going to be a little bit different, because it's like you have like a loan. The way you'd want to think about it is you kind of have an account with like a negative amount of money in it, and every month then you're paying until you get back to zero. So the equation looks a little bit different because, a loan stops when you get to zero. Like, you don't keep paying your loan forever, right? And this PV, instead of thinking about this as present value, it's really kind of more like the principal value. So that's like the amount that you borrowed. In a way, you can think of it as a present value, like, hey, this is how much at the very beginning of this, if I took out a loan for $10,000, well, I have $10,000. So it's kind of like the present value in that sense. But it's really the amount borrowed is what you want to think about that as. So let's do, I got 2 more examples and we can be donezo. How's that sound? Nobody's objecting, so I think that's probably a good thing. I mean, do you want to keep going? I can keep talking about stuff. So here it says Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan if she makes a $2,000 down payment and the annual interest rate is 2.9%? So I hear loan, and I'm quite confident I'm going to be using the my loan annuity formula. What are we asking to solve for in this problem? Yeah, what are the monthly payments? So we're looking for R. Great. So let's start filling some stuff in then. What is the PV? It is actually not 18,000 and it is not 2,000. So remind me again, what does it look like when you walk in and you buy a car? Okay. So what does the transaction look like? You usually pay some kind of a down payment and then you borrow the rest, right? So the principal value is the amount we borrowed, which in this case should be the price minus the down payment. And again, if you've never gone car shopping before, gone with a parent while they were car shopping and paid attention to what was going on, it's like, oh, sure, when you explain it makes sense. It may be not totally obvious right from the get-go, which it seemed like it wasn't, but that's okay. That's why we're doing the examples. Everybody go to that? To calculate little I, we need R, the interest rate, which is 2.9 over 100K. What's the K in this case? Nope. It's how often you're making your payment. So it's 12. And what's the little n then in this case? 4. Okay. So to solve for R, I'm just going to divide both sides by this whole big fraction. Yes, Lexi.
How did we get to 16?
So the amount borrowed is the price minus the down payment. So 18,000 minus 2,000. Is that okay? All right. So here, if I haven't been using my fraction command in my calculator, boy howdy, do you want to be doing it now, because it makes life a lot easier. Because you'll see how many times I'm going to take advantage of that. I think 5 times I'm going to use the fraction command to do this. So it's 5 fewer sets of parentheses than I really need. Or that I don't need, you know what I mean? Which, that's a whole heaping lot of parentheses that I can get away with not having to use, which is very nice, right? Ooh boy, don't do that. So I do that, I get 364.49. So that's how much my payment is. And that's probably the piece when you're considering taking a loan to buy something, the piece that you're probably most interested in, right? Clearly you don't have enough money to buy the thing all at once. The big question is, do I have enough money to make these payments every month, right? Whether it's a house or a car or, small business loan or whatever. It's hey, can I make this payment every month? All right. So we're going to buy this car and we're going to pay $364.49 each month. Kind of the natural next question is going to be, well, how much do I end up paying for the car in total, and then how much interest did I end up paying, right? So we'll do the total cost first. What did I end up paying for this car? What are all the costs or all the things I had to pay? What did I start by doing? Okay, so I had my $2,000 down payment. Then what did I do? Okay, I got my loan, and to pay that back, I do. Okay, so every month. And then for 4 years. Everybody cool with that? That's the what I end up paying for that car? So $19,495.41. So the amount of interest I ended up paying for this, how would I calculate that? Well, I'll take the total costs and then subtract off what? Yeah, the price. So in that case, that's $19,495 minus $18,500. And I get $995.41. That I end up paying in interest. What do you guys think? Not that big of a deal, I hope, right? More or less, these problems should feel pretty comfortable. That finishes up section 15.5, so we can now finish out the problem set. So 156 through 184. That's going to go in, 139 is where we're at. My bad. Through 184. If you look, I'm going to put that part also on next week's problem set. So for Friday, or for Sunday, you guys have 71 to 130. For next Sunday, you have 131 to 184 in the review, which I haven't posted yet, but I will try to get that up there today. Looking ahead, next class, we're going to do the review day for Chapter 15, and then we'll take the test the following class period. To close out the semester, I think that I would like to do I'd like to do chapter 14 next. And then I think I can probably do chapter 12 in a day. So those two would be what I'd like to finish. To do both of them with the time we have, we'll probably not test either one of them. We'll just put them onto the final and not have a chapter test on them. Unless there's some serious objections. But I think we'll have done 6 or 7 tests, not counting the exam. So I think that's certainly enough to get a good gauge as to what's going on. And I'd rather be able to cover a little bit more content and skip those final couple skip a test or two there. Does that feel okay to you guys? Okay. We'll talk more details as we get a little bit closer, but that's kind of what I'm thinking. Counting the number of days that we have left and everything, I think we can should be able to do both of those 2 chapters, but I don't think we could do both of those 2 chapters and take tests, which is my motivation for, not wanting to, I'd rather cover the content and do one or two fewer tests. You know what I mean? Plus, I'm sure that other classes at the end of the semester are really trying to cram some stuff home with projects and other things. So if I can lighten the load a little bit there for you guys, I think that's probably appreciated. Okay. That'll do it for me. You guys have 30 minutes or so that you can start on